Being a brain has alienated all my friends.
Dad, as intelligence goes up, happiness often goes down. In fact, I made a graph. I make a lot of graphs.
Okay, guys, let's begin the last lesson of the semester. This will be the very last lesson. We're not gonna go beyond topic 2.6. I already talked to the coordinators, and they told me, well, at least Alejandro, specifically Alejandro Moreno, told me that it was okay to stop the topics right now because we have no more time to go, and the final exam of mathematics will be next Tuesday, so we cannot cram any other material in the course. Okay, we're gonna stop it right here, 2.6, and the coordinators are working on how we can heal this deficiency in the topics, not just mathematics, but all the subjects. So they're working on that. And when I get notice of what we're supposed to do, I'm gonna tell you. Okay, I'm gonna notify you. So this is the last topic, 2.6. Okay, what was the last thing we did in the first part? We did this exercise. We put these standard forms of the quadratic function, as you may remember, into the factor form, which looks like this. And remember what I told you, that I didn't explain in detail how that worked. Okay, I just told you, do this, do this, do this, and voila, you get the full result. And it works. Okay, it's a correct result, but there is no explanation involved. You're not really understanding what you're doing. You understand how to do it, not why you do it. And that's not education, but due to the time constraints, we have to do that. And just as a parenthesis, quick parenthesis, because I think this is a very nice idea. What we did in this exercise in science and engineering and mathematics sometimes, that is known as a black box. Mathematics and engineering. A black box is something like a process or a device in which you put information or you put any input and you get something as an output. It's kind of like a function, right? But you don't know what's happening inside. You cannot see it, okay? Either because it's too complex or for whatever reason. You just don't know how this box is working. The box does some work for you and it gives good results and all, but you're not seeing what's inside. That's a black box. And on the other hand, we have the concept of a white box, or sometimes called a glass box or a crystal box, in which it's the same idea. Okay, it's a device or a process or a method in which you get input inside and you take some output at the end, but in this case you're actually seeing what's inside. You see how everything connects inside, all the rods and the gears. And I'm just trying to describe like general machinery, gears and granes. You know how it works internally. Okay, so there is no mystery in a white box. There is no mystery. Your brain goes like, oh, okay, I get it. And this is understanding as opposed to this. Okay, so the purpose of education is actually for you to convert black boxes into white boxes. That is what education is, guys, in the end. By the end of your education process, which should not end, by the way, ever, like you should always be learning stuff, but the whole purpose is converting black boxes, going from this part into this part, into white boxes. Okay, that is the whole purpose of being an educated person. If you keep on doing things in this part, okay, only black boxes, yeah, I mean, you can do a lot of things, but if you don't understand what's inside the processes, you're wasting your time completely. Okay, so that's just a quick idea for you. Investigate these concepts. It's very cool, philosophically speaking. Okay, so what we did over here was a black box. And on the other hand, in the next exercise, which is this, we're gonna look at a white box now. Okay, I'm gonna explain in detail how to do this exercise, and that's why I'm calling this a white box. So it's basically the same. Look, in the last exercise, we had these two functions and we put them into factor form, these two functions. And on the next exercise that we're gonna perform right now, it's the same two functions, quadratic functions, but now we're gonna put them into vertex form, and like I repeat, we're gonna do it as by a white box, so to speak. We're gonna understand what we're doing. Okay, so a little background first in order to go into this. We need to I need to remind you of two concepts. The perfect square trinomial, I'm gonna represent that by PSD, perfect square trinomial, and the technique of completing the perfect square trinomial. You saw these things last semester, or you must have seen them, okay? These two techniques. But I know since that was a long time ago, you may have forgotten about this, so I'm going to remind you very quickly. So first, what is a perfect square trinomial? What is that? What is the definition? The definition of a perfect square trinomial is the result the result of elevating a linear binomial to the square. So when I raise this to the square, I get x squared plus 2x plus 1. This is by definition a perfect square trinomial because it's the result of a linear binomial raised to the square. What do I mean by linear? What I mean is that the exponent of the x is at most 1. If I wrote a 3 right there, this is not a linear binomial. That's a linear binomial. I'm going to give you another example. 2x minus 1 to the square. This is a linear binomial raised to the square. If I perform that exponentiation, I get 4x squared minus 4x plus 1, and this is a perfect square trinomial. So that is the definition. Okay, next. The technique of completing the PST, the perfect square trinomial. How does that work? What is that in the first place? What is that? Okay, the problem is this, guys, that when you receive any general quadratic expression, for example, this one, this is a quadratic expression, okay? A trinomial that is quadratic. Okay, in most cases, these things are not gonna be perfect square trinomials. Okay, this is a trinomial and it's squared, that's okay, but it's not perfect. Okay, because if you try to put this as the result of a binomial to the square, you're gonna fail. You won't find a binomial, linear binomial, such that raised to the square will give you this. You won't. Okay, so can we do something similar to this? Yes. Yes. What we can do instead is converting this general trinomial that is squared into a binomial to the square plus a little number, a little extra constant. Okay, so we can almost shape it in the form of a perfect square trinomial. Okay, because remember, this the result of this is a perfect square trinomial, but at most what we can do with any general quadratic trinomial is to make it equal to a perfect square trinomial plus a little extra number. That is the thing that we can do for any general quadratic trinomial. So we're gonna do it in this specific case. I'm gonna remind you very quickly how that was done. And you're gonna remember very quickly how this worked. Okay, so what do we do? How do we do that? What we do is this. First we write the same quadratic trinomial that we are given. We just write it down like that. And what we do next is we're going to add a number and we're going to subtract that number at the same time. I'm going to add a number and subtract that same number because I cannot change this thing, okay? I have to keep it the same. And the only way, well, one of the only ways in which we can do this is by adding and subtracting the same number. Okay, what number am I going to add and subtract at the same time? You're going to add the square of half of this number. I repeat, the square of half of this number, this coefficient, the coefficient of the x. So what is the half of this number? 5 over 2, right? And I'm just going to keep it that way. I'm not going to divide it. I'm not going to do this. Okay? I mean this is equal, I'm sorry. But I'm not going to go into the decimal. I'm just going to keep it like this. So this is half of this number, 5 over 2. And I'm going to square it. And I'm going to add it over here. So 5 over 2 to the square. The square of half of this number. Can you see? Okay. And I'm going to subtract that same number. Minus 5 over 2 squared. Adding and subtracting the same number. So I'm really not changing this because this is basically 0. Okay, next, what do we do next? We continue writing this whole expression. We begin x squared plus 5x, and now I'm gonna do a little rearranging of the terms. First, I'm gonna write this, and then this, and then the last one. Always in that order. And finally, what we get is this. This trinomial, if you notice, that is a perfect square trinomial already. And what is the binomial that when we raise it to the square, we get all of this? The binomial is this. X plus this number. 5 over 2 to the square. If you're not convinced that this is the same as this, try to raise this binomial to the square. Okay? And you're gonna get all of this. If you want, pause the video for a moment or later on, and you will convince yourself that this is in fact the same as all of this. So a binomial to the square is this. So therefore this is a perfect square trinomial. And we have these two remaining terms over here. Minus 2 minus 5 over 2 to the square. Okay, fine. And as you can see, we are done because we converted a general quadratic trinomial into this. It's the same as this, which is a perfect square trinomial. This is a perfect square trinomial, okay? And plus, all of this is a number, okay? All of this can be understood as a number. If you perform this, the exponentiation, and then you subtract 2 and blah, 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 this, in the end, you will get a number, which is what I told you, okay? We can put this as a perfect square trinomial plus another constant. So we are done. This is the technique of completing the perfect square trinomial. This is how it works. I hope that you have remembered that by now, but because I'm just going to give you this example. Okay, so let's begin. Number 1, we have this function. It's in the standard form, quadratic standard form, and we want to put it like this, in the vertex form. Okay, so how do we start? I'm going to start my 2. And then, what I want to do first is this. I'm going to factor this trinomial in this way. I'm going to choose the coefficient of the x squared, which is 2, as the common factor. And you may be thinking, well, that is incorrect because not all of these terms have the 2 as a common factor. And I agree, because I mean the 3 doesn't have 2 as a factor. I get it. But what you can do is this. You can write 2 that multiplies x squared, because 2 times x squared is this. And then you can, for the next term, you can write this, 3 halves of x. Why? Because when you multiply 2 times all of this, you will get this. Can you see what I did? This 2 cancels this 2, and all that you get in the end is 3x. That's how it works. And then what number goes in here? It's going to be minus 1, right? Because 2 times minus 1 is minus 2. So that's the first thing you're going to do. Factor this trinomial in this way, by choosing the coefficient of the x squared as a common factor. And you do this. Okay, next step. We write f of x equals 2 times this trinomial. Okay, let's forget a little bit about the 2, and let's only focus on this part. Let's focus on this. I'm going to bring this over here, and I'm going to work on that. And you're going to see what I mean by working on this in a moment. So I just put it here. Okay, and what I want to do is this. This is a general quadratic term. I'm sorry, a general quadratic expression. And what I want to do is apply the technique of completing the perfect square trinomial to this expression. Okay, so let's begin. What do I do? I write it down, and I'm gonna add and subtract the same number. Okay, what number? The square of half of this number. I repeat, the square of half of this number. What is the half of this number? The half is 3/4. The half of this is 3/4. And now just square it and keep it like that. Don't perform the squaring yet. Just keep it like this and just add it over here. 3/4 to the square, and the same as a subtraction. Okay, that's what you're supposed to do. Next, let's rearrange the terms. This is going to be x squared plus 3/2 times x, and then I write this number plus 3/4 to the square, and then the minus 1, and then minus 3/4 to the square. And like I told you before, all of this is already a perfect square trinomial. What is the binomial? What is the linear binomial such that by raising it to the square I get all of this? It's this. X, you always begin with x, plus this number, 3/4. 3/4 to the square. Again, if you don't believe me, raise this binomial to the square, and you will get this trinomial. Okay, so make sure if you want. And then we have minus 1 minus 3/4 to the square. Now, in this case, I do want to compress all of this, to simplify it, all of this into a single number. So how much is this? That's going to be, let's do it over here. That's going to be minus 1 minus 9/16, right? And that's going to be equal to minus 16/16, because that's minus 1, minus 9/16, and this is going to be equal to minus 25/16. Yeah, right? Yes. Okay, so this is the final simplification. So this is minus 25/16. So basically, what is the end result of this whole process? Remember, we took this general quadratic general quadratic expression, we put it here, and we complete the perfect square trinomial on that expression, and what we get is that all of this is the same, completely the same as all of this. Okay, this and this are exactly the same, so I can take this back and put it back in here. So it's gonna be the number 2. Remember, we forgot for a moment about the number 2, but it is there, it is still there. 2 times all of this, but what is all of this? It's equal to all of this. So I open a new square, a bracket or something, and then I introduce all of this thing in here. So here we go, x plus 3 over 4 to the square minus 25 over 16. We close brackets and we are almost done, almost. Now let's just now multiply the 2 times these brackets. So it's 2 times this, and I'm just gonna leave it expressed. I'm not gonna actually perform that. And then 2 times minus 25 over 16. So I'm gonna get minus 50 over 16. And we are done. We are done. This is already the vertex form, guys. Why? Because look at the vertex form. Look at all of this. Look at all of this. The vertex form is some number times a linear binomial in this form to the square plus another number, which is basically what we have in here. And remember, we don't have the plus exactly, okay? We have a minus. So I can do just a very small trick. Oh, and by the way, I have to do the same in here because we have a plus. Okay, so it's a greater opportunity to do it once again. So I must change this into this minus times minus 3/4, like so, to the square, and then plus minus 15 over 16. Now this is the actual final result. This is the actual vertex form, because now all of this, I'm gonna divide this section, all of this now has exactly the same shape as this. Make sure, I give you some seconds. So it checks, right? Okay, so it may have seemed like a long process, but with practice you can get it done rather quickly. Okay, it's not that difficult. So basically, the first function in standard form is the same as this one into vertex form. Okay, one more. This one, f of x equals minus 2x squared minus x plus 3. Okay, what do we do first? We factor this trinomial by using the coefficient of the x squared. I'm gonna separate minus 2 that multiplies what 3 terms? Well, first of all, x squared, because minus 2 times x squared is gonna give me this. And then by what number should I multiply in order so that minus 2 times that number gives me minus x? Well, that's gonna be plus 1/2 of x. Make sure this times this will give you this. Okay, and you just need practice in order to recognize this quickly. Okay, in order to come up with this number quickly. And then minus 2 times what number gives me plus 3? It's gonna be minus 3 over 2, because when I multiply minus 2 times minus 3/2, I'm gonna get plus 3. Again, make sure quickly. This should be done very comfortably in your mind. It's not hard. Okay, once we do this, Remember, we take this trinomial in a separate section of our sheet of paper or something. We put it there and we apply the technique of completing the perfect square trinomial. So this is equal to x squared plus 1/2 of x minus 3 over half plus some number minus the same number. What number? The square of half of this number. First of all, what is half of this number? Is 1/4. That is the half of this number. And then I just square it. So this number is the square of half of this number. And that's the number that I'm going to add over here and also subtract like that. And then I can erase this. Okay, like that. Then we rearrange terms one more time. So x squared plus 1/2 of x. First I'm going to write this plus 1/4 to the square, and then this, minus 3/2 minus 1/4 to the square. Okay, this is already a PST, a perfect square trinomial. What is that binomial raised to the square? That's going to give me this as a result. It's going to be x plus this one to the square. Okay, x plus 1/4 to the square is going to give me all of this. Minus 3/2 minus 1/4 to the square. And then we simplify all of this. I'm going to do it over here. Minus 3/2 minus, how much is 1/4 to the square? It's going to be minus 1/16, right? So how much is all of this? It's going to be minus 24/16. Yes, minus 1/16, and that's going to be minus, that's actually, I think it's the same as before, right? Minus 25/16. So this is the end product, minus 25/16. So all of this in the end is minus 25/16. Let me check because I don't want to make mistakes. Yes, it's correct. So I can replace all that was here by minus 25/16. Okay, and we're done. All of this quadratic expression is equal to all of this. A perfect square trinomial plus another constant. Okay, so I'm gonna take it back to my original working, and I'm gonna write this. Then we have f of x equals minus 2. Don't forget the minus 2, the coefficient that multiplies all of this, which is all of this. So I'm just going to introduce it as I see it, like that. And then finally, I just multiply the minus 2 times all of these brackets. So I'm going to get minus 2 times x plus 1/4 to the square, and then minus 2 times minus 25/16. So it's going to be plus 15/16. And we're almost done. Now we just give it the shape, the complete shape as this. Okay, we need a minus and a plus instead of a plus, and well, we already have the plus, so that's okay. We only have to change this one. So it's gonna be f of x equals minus 2 that multiplies x minus 1/4 to the square plus 15/16. and we are done. So again, it seems laborious, and it is, to a certain extent, it is a lot of work maybe, but it's simple. Okay, once you get the idea, it's simple. So this is the same as this, okay, and this already is in the vertex form. Okay, make sure to understand why. We have a number, and then a binomial of this form, x minus another number, x minus another number, raised to the square, plus, plus, number, number. We're done. This is it, guys. So that's how you transform a function, a quadratic function, in the standard form into the vertex form. By basically what we're doing is some algebraic trickery and completing the perfect square trinomial. That's basically what we are doing. And I hope that you have understood why this is a white box. This process was a white box because I told you how it worked. Okay? And if you didn't understand, well, that's because you were not paying close attention, or I don't know. I mean, maybe by going over this twice or three times, you will get it. But the thing is that I explained why it worked. That's the idea. Okay, let me see how long this class has been already. Just give me a moment. Okay. Okay. So I believe I want to cut this lesson right now. Um, okay, we're done with this, with the point number 2. Remember that there are 3 points in this lesson. Let me remind you, it's these 3 points, these 3 objectives. We have gone um, we have gone through the first one and the second one, and the number 3, which is the study of the most important features of the quadratic function. All of these things, I'm gonna do that in a third part because it's already half an hour of explanation. I don't like to do very long explanations because you get tired, and your attention span is not. I mean, the attention span of any human being is not that long. So I'm gonna keep the number 3 for the last part, and you have to watch it later, like on Saturday or Friday, or I don't know, whenever you can. This one is gonna be about 15 minutes long. I reckon 15 or 20 minutes. Okay, guys. So I believe this is it. This is it from me. This is basically the last lesson, at least in this week. And I want to have a couple of minutes to thank you for the semester, guys, for your enthusiasm, for your time. It was a great time for me being your teacher, being the teacher of an IB of 3 IB groups. I just enjoy it a lot. And I'm gonna take a couple of minutes, maybe 3 or 4 minutes, for you to listen to me because this is important for me to say. Um, I, I believe in this program a lot. I believe it in this program. That's why even though it's a lot of work to do, the level of the quality in the classes has to be much higher than any other high school program. I enjoy it. I enjoy spending a lot of time thinking about what things I'm gonna say to you, in what ways, what is the best option to teach you, etc. I enjoy it. I enjoy the whole process because I believe in this program, because I believe in you, because I believe that you must go beyond the education of any normal person. Okay, it's what we're doing with you is try to make you into the best possible citizens, or the best possible people that we can in the IB program. So thank you so much, guys. I just that's what I want to say. I don't want to get too deep into this. Thank you so much. I can only hope that they give me again the opportunity to work with you in the next semester. I promise it's gonna be much better. I'm learning new tools, etc. And that's it, guys. Thank you so much. You've been great. And get smarter. Get smarter every day. There's nothing better than that.
¿Ya qué?
Ya empiezo a preocuparme por Lisa. Salió hace varias horas.
En su lugar compraría un enorme pastel para disculparme.
Las autoridades temen que la ola de toallas secuestros empeore antes que mejorar. Y ahora en la respuesta editorial, aquí está una pequeña.
Hola, mi nombre es Lisa Simpson.
¡Oh!
Se supone que debo hablarles sobre la propuesta de ley 305.
Malditas viudas de guerra.
Pero tengo algo más importante que decirles. Por razones más allá de mi control, en breve me convertiré en un ser insípido, indolente y estúpido. Así que antes de que eso pase, quiero compartir con ustedes las cosas que tienen un gran significado para mí.
micrófono.
No. Deja que hable. Quiero que me despidan.
Y por favor, no se priven de libros tan maravillosos como Matar a un ruiseñor, Harriet la espía y Yertle la tortuga. Posiblemente el mejor libro que se haya escrito sobre el nacimiento de las tortugas.
En eso tiene razón.
La belleza nos rodea y no solo en concursos y estéticas. Puede encontrarla en el movimiento de las galaxias o en el movimiento que hay en el centro de un girasol.
Excelente idea. Vamos por unas malteadas.
Homero, tu hija está abriendo su corazón.
Pues grábalo.
¿Por qué estás diciendo eso, Agoniza?
Por favor, les suplico no resten valor a su cerebro. Es el mejor amigo que podrán tener.
A esta criatura le agrada su cerebro. ¿Ustedes qué opinan?